Hello everyone. So let us try to solve this question. So let us try to read fast. Okay. So here is the question you can see. Right. So here it is saying that two cylinders P and Q rest in a channel as shown in the figure. So there are two cylinders we can see over here. One is P, other one is Q. Right. So this is a channel. So the cylinder P has a diameter of 100 mm and weighs about 200 Newton, whereas the cylinder Q has a diameter of 180 mm and weighs about 500 Newton. If the bottom weight of this box channel, which I am talking about, uh, that is given to us as 180 mm. So with one side is vertical and the other one is inclined at 60 degrees. So here you can see in the figure. So this is one side of this particular channel where it is vertical and this side is inclined at 60 degree to the horizontal, right? So need to determine the pressures at all these 4 points of contact. So here basically pressure means we need to find out the reaction forces and assuming the area of contact is 1, right? Okay. So here we are having 4 contact points. So I have shown over here. Let this is the contact point 1, 2. This is the contact point 3, and this is the 4 one. Right. The contact between the cylinders P and Q. Right. Okay. So here I have noted down all those given datas like diameter of the cylinder P, which is given to us as 100 mm. From that we can find out the radius, that is as 50 mm. Right. Then WP, weight of the P, is given to us as 200 Newton. Diameter of Q 180. As a result of that, the radius of Q is 90 mm. So WQ, weight of the cylinder Q, which is given to us as 500 Newton. Right. Okay. So now let us try to draw the free body diagram for solving this particular question. Here I have drawn the free body diagram for this cylinder, right? So will be making it free from all these supports or surfaces with which it is in contact. So I have drawn the simple cylinder over here, right? So after that we have to show all these acting or reaction forces. So here basically it is this WP, it is the weight of this particular cylinder P, which will be acting in the downward direction. So we'll be getting another reaction over here. It will be perpendicular to this particular contact point, that is wall. Right. So here it will be if I'll be taking this is as a positive x direction and this is positive y direction, then in that case this will be your in the negative y direction, right? So here I'm noting it as R1. Then R4, the contact between the cylinder P and Q. So it will be acting, I'm assuming, at an angle of theta 1 with this horizontal. Of course, we need to find out this angle for solving this particular question. For finding all these unknowns over here, we need to find out all these angles, right? So of course, if I'll be saying this is theta 1, then this total angle between WP and R4, which will be your, this is 90 plus this is theta 1. So 90 plus theta 1, right? Okay. So after calculating the value of theta 1, we'll be able to find out the value of this value, right? So we're getting this one, so we'll be looking into that, right? Then so this is theta 1 and this total angle we know that is 180. So 180 minus theta 1, that will be the angle between R1 and 4, R4, right? Okay. Moving further, let us try to draw the free body diagram for this cylinder Q. So again, we need to make it free from all these surfaces with which it is in contact, right? So here I am having 3 points, 3 contact points for this particular cylinder Q. We'll be getting 3 reactions over here, and another uh, that is weight W, right? So here we have taken R4 is it is acting at an angle of theta 1. So when we'll be extending in this region, so this theta 1 will be equal to this one, this side. So R4 will be acting in this direction at an angle of theta 1, right? And R3, so here we'll be getting from this particular support, this particular contact point basically will be getting the reaction which will be obviously passing through this particular center point of this particular cylinder. So this is, and this is one where we'll be getting the reaction R2 which will be perpendicular to this particular plane, right? So R2. Okay, so this is how we have completed the drawing of these free body diagrams for both these cylinders P and Q. Okay, now we'll be interested to find out the value of these two angles, that is theta 1 and theta 2. Okay, so for that let us do some constructions. Like here I have joined this point, that is the center point of P and the center point of Q, right? And I have named this as O and this is O double prime, right? And this distance here you can see, because this is the addition of these two radius, right? So this is diameter is having the 100 mm, so radius will be 50 and here it will be 90. So this total length, the total center distance between the P and Q, that will be equal to 140, right? Okay, so now I have constructed one triangle over here where this will be the theta 1 which we are interested in for the calculation, right? Okay, so if we'll be looking into this particular triangle, that is O double prime, O, O prime. So in this triangle, if we'll be able to find out this particular length, that is O, O prime, then of course by using cosine of this theta, we'll be able to find out the value of theta 1. Okay, so to find out this value, let us do some more construction. Okay, now at this particular tangent point where this particular cylinder Q is in contact, I am drawing this O. I have extended from this O to this particular tangent point and extended it further, right? So obviously this angle here we can see that will be 90 degree. Okay, and of course in this side this will also be 90 degree. Okay, and this angle it is given to us as 60 degree. And when I'm saying this is a right angle triangle, so from this triangle we can see if this is 60 degree and this is 90 degree, of course this will be your 30 degree. Okay, I hope it is clear. Okay, so now let us see and let us compare these two triangles. So let me try to show you, that is from here I'm starting this triangle where we found out this angle, right? So this angle as 30 degree, this one actually. And if you'll be comparing this triangle with this one, like here I can say, so this is the triangle I am talking about. So if we'll be comparing this triangle with this triangle, then we can see this is 90 degree and this is also 90 degree. And here this side, right, base, this base is same for both these triangles actually, right? And from that we can conclude something, that these two triangles are similar, right? So that I can say this angle which is 30 degree over here, here this angle will also be 30 degree. Okay, and if it is 30 degree, then we can say this is 60 degree, right? So here you can say this is 30 degree we got, right? And when I'm saying this is 30 degree, obviously this angle which we are talking about, this angle it is basically making with horizontal 30 degree. So r 3, right, in this particular free body diagram, the angle which we were talking about, that is theta 2, we got this is a 30 degree. Okay, now, so now here we got this angle is 60 because this is 90 and this is 30, so obviously this angle will be equal to 60. And when these two angles, like here this angle is 60, this is 60, then obviously this angle will be 60. Okay, now if we'll be looking into this particular triangle here, OAB, right? So this, in this OAB triangle we can see this angle is 60, and here we can see this length, right, OB, it is nothing but the radius of this particular cylinder, that is Q. Okay, and if we know this value and this angle, of course we can find out the value of this AB. So why am I interested for this particular length AB? Let us try to understand that. Because we want to find out the angle this theta 1, right? So for this particular triangle, we know this side, that is 50, and this is 90. This summation will be equal to 140, right? And now, by any means, if I'll be able to find out this side, that is O and O prime, in that case, I can find out the value of theta 1, right? So for that, okay, and this length is given to us, this width of this particular channel, which is given to us as 180 mm, and it will be deducting this length, this one, which is nothing but the radius of this cylinder P, and this portion which I was talking about, that is AB, right? Then obviously I can find out the value of O prime, right? So for that, I'll be requiring this length, right? So now in this triangle OAB triangle, right? If I'll be taking sine 60, then of course I can write as this is perpendicular, that is OB divided by AB, right? So that I have written over here tan 60, that will be equal to OB divided by AB, right? Now I was interested to find out the value of AB over here, right? So AB will be equal to OB divided by tan 30, and OB, we know this one, right? OB, right? This is the radius of this particular cylinder, that is Q, and that is given to us as 90 mm, and divided by 10 per 60. So here I'll be getting the value of AB, that is 51.96 mm. After calculating that, we can find out the value of O prime. That means simply this length. So that will be equal to this total length, that was 180 mm, minus this radius, which was your 50 mm, minus this distance, that is AB, which we just now calculated, that is your 51.96 mm. So from here, we calculated the value of this your 70 O prime, that is as 78.04 mm. Right? Now let us use all these data in this particular triangle, that is O prime, O double prime. So if we be taking cosine of theta 1, okay, in that case we'll be finding that as base by hypotenuse, that is O prime divided by O double prime, right? So these two values are known to us. I just put it over here, that is 78.04 divided by 140, and from this, I calculated the value of theta 1, which is equal to 56.12 degree, right? So we calculated the value of theta 1, that is equal to 56.12, and previously we found out the value of theta 2, that is as 30 degree, right? Now if I'm putting over here theta 1 as 56.12, so here this angle between R4 and WP, that will be equal to 146.12 degree, right? And the angle between R1 and R4, that can be found out as 123.88 degree. Okay, so after calculating these angles, there is nothing to solve. Simply you have to use equilibrium equation or Lami's theorem, whatever we have studied, right? So now let us try to apply the Lami's theorem in this particular free body diagram of cylinder P, right? So if we are applying the Lami's theorem in this cylinder, that is in this particular free body diagram, so here I can write WP divided by sine of the angle between R1 and R4, which is given to us as 123.88. That will be equal to R1 divided by this angle, which is your this is sine of this particular angle, that is 146.14. That will be equal to R4 divided by sine of this angle, which is nothing but 90 degree, right? Now we need to compare these two terms for calculating the value of R1. Okay, and here WP value is given to us as 200 Newton, right? 200 multiplied by sine of this one and divided by sine of this one, that is 123.88, will be able to find out the value of R1, that is 134.29 Newton. Okay, now we need to compare these two terms, that is WPY something, that is sine of 123.88, that will be equal to R4 by sine 90, right? So if we'll be comparing that, then of course we'll be able to find out the value of R4, right? So 200, which is the value of WP, multiplied by 1, right? that is the sine 90 value, divided by sine of 123.88. So from here I can find out the value of R4, that is 240.9 Newton. So from the free body diagram of cylinder P, we found out the value of R1 and R4. Right now, for finding the rest contact forces or the contact reactions, we need to apply the equilibrium equations or Lami's theorem to the cylinder Q. Right, the free body diagram of the cylinder Q. Right now, when we are going to the free body diagram of cylinder Q. So here you can see that there are basically four forces. Okay? And if we'll be trying to apply the Lami's equation, then at least for that we should have three forces under equilibrium. So if we want to apply the Lami's equation, then we can convert this R2 and W2 into a single force, because they are along the vertical direction, positive or negative y direction, so they can be clubbed into a single equation. If I'll be trying to in the write in the negative y, then I can write it as W2 minus R2, or if I want to write in the direction of positive y, then I can write R2 minus W2, FWQ, sorry, this is WQ. Okay, so I can do like that, and that is how we can combine these two forces into a single force, and directly we can use the Lami's theorem, right? But I have solved this by using the equilibrium equations like summation of fx equal to 0 and summation of fy equal to 0, because already we have used the Lami's theorem in the previous case. So that if we be using the equilibrium equation, we'll be getting some exposure to that also, right? Okay, so here will be first I have applied here summation of fx equal to 0, all the forces along x-axis that will equal to 0. In that case, there is no component of R2 and WQ along x-axis, right? So only we'll be getting the component of R3 and R4, and of course this is due to R3 will be getting a force along the positive x, and due to R4 will be getting the force along negative x, right? And basically if we were applying this particular equation, then I can write R3 cos theta 2, that will be equal to R4 cos theta 1, right? And from here already we have calculated the value of R4 as 240.9, and theta 1 already we know this value, that is 56.12, and theta 2 as 30 degree, right? So from here I'll be able to find out the value of R3 as approximately 154.48 Newton, 48 Newton, right? Okay. Now let us apply the other equilibrium equation I am having with, that is summation of Fy is equal to 0, where I have to take all the forces, all the component of all these forces in the y direction, right? So here I'll be getting a positive force, positive component of this R3 force along y direction, and I'll be getting a negative force, negative component of force, that is due to R4 and of course WQ and R2, right? So here so I'm taking all these positive force are in one side, and all the negative forces in the other side, right? So here I'm having this R2 and the sine component of R3, that is R2 plus R3 plus R3 sine theta 2, right? And again WQ plus the sine component of R4, so WQ plus R4 sine theta 1, where WQ value is given to us as 500 Newton, and we know the value of R4 as 240.9 and theta 1 as 56.12, and just now we calculated the value of R3, that is as 154.48 multiplied by the sine theta 2, which is 30 degree. Now from here I am having one unknown, that is R2, which can be calculated as 622.79 Newton. Okay, so hope you got it in a proper manner. Try to see the video once again, and if you will be facing any doubt, please free to contact, comment in the comment box, and I'll be definitely happy to answer that. So thank you.